All right, welcome back. And now we're going to talk more about the polar coordinate system here. Okay. So a couple of things here. If we start with a point, r comma theta, as we saw in the last example, we saw that what? We saw that if I go one revolution around the circle, I get the same back on the same point, which is coterminal, right? We have a coterminal angle that coincide. So what I know is that if I take any angle and I add 2 pi to it, it's going to give me the same angle. It's going to give me right back to where I started. So this is going to equal the same as r theta plus or minus 2 pi, right? So if I add or subtract 2 pi, I will get the same point. Okay? Also, we can play around with the directed distance, right? So for example, okay, so let's do this. If I start here, right? I had that point. So obviously if I go this way, 2 pi, right? 1 revolution, I get the same point. Or if I go clockwise, 2 pi, I go to the same point. So I can add or subtract any multiple of 2 pi. In fact, in general, I would just put in 2n pi, right? Plus or minus any multiple of 2 pi, where n is an integer, will give me a coterminal angle. Okay, or give me a coinciding points. Okay, so they'd be represent the same points. Or I can also play around with r as well, the direction, right? Or the not the direction, the direction. Okay, the directed distance. Okay. So let's say I have this point again, right? So let's say so we know this, right? So this is going to equal r theta plus or minus 2n pi, okay? And then let's say again we have our point, right? So here's r and here's theta. Now I could also, what if I do this? What if I go 180 degrees, right? What if I go 180 degrees, right? So I take this and I go 180 degrees, which is pi, right? Okay. Now what happens over here? Now I'm over here, right? Right? So now r is over here. But what if I take the opposite of r? Well, the opposite of r would reflect across the origin and bring me right back to where I started from. So that's another way to get the same point, right? So what I can do is I could take r comma theta and I can what? Add or subtract pi from theta, to or from theta, but then take the opposite of r and I will get right back to where I started. So I can write it more generally, I can say, okay, this point is going to be the same as negative r, but then I have to add or subtract pi or some multiple, oops, hold on. Hold on. Gotta be careful here. I'm gonna say pi. Let's just start with pi. So add or subtract pi, right? Now, I don't want to I don't want to say 2 pi because that's not going to give me the same place. So let's start with pi, right? So if I add or subtract pi, as long as I take the opposite sign of the directed distance, r, I'll be fine. Now, how would I more generalize this? Well, I can do this, right? So, let's say I want to do every odd. So here, I can make this more general by saying, okay, let's add a multiple of 2 pi plus pi, right? That'll work too, right? If I go one more, right? Or 3 pi, right? So 3 pi will work. In fact, if I do any multiple of 2 pi, right? So if I go 2n pi plus another pi, that'll work. So that'll work, right? So as long as I take any multiple of 2 pi, right? And then add another pi. So if I start here, right, I can go any multiple of 2 pi and then add one more pi and then take the negative and that'll get me right back to where I started from. So this will work. So in other words, if I simplify this a little more, I can write this as equal to negative r comma beta plus or minus what? It'd be 2n plus 1 times pi. So if n is 0, I get 1. If n is 1, I get 3. If n is 2, I get 5. So basically, like I said, any odd multiple of pi. So 1, 3, 5, 7, 9, 11, and so on. Okay, so that will work. All right, so there's another general form for finding different ways of representing the same point. Now, so unlike in the rectangular system, right, the rectangular coordinate system, you have one way and only one way, a unique way of representing any point in the plane. That is not so using the polar coordinate system. So representing a point in the polar coordinate system there's an infinite number of ways of representing that point. Okay, like I said, unlike in the rectangular coordinate system or the Cartesian coordinate system, there's only one unique way. All right. Have a great day.